Hello, I would be giving you one simple task. You are given with 100 grams of water, one side, another side 10 kilogram of water. Maybe this is to drink hot water and this is to take hot water bath. But it's water. And temperature is going to be same initially 30 degrees Celsius, comfortable room temperature. Now I want you to increase the temperature from 30 to 40. Okay, maybe 30 to 40 degree I want you to increase. One side 100 gram of water, another side 10 kilogram of water. Mass of the substance is more in case of 10 kilogram compared to 100 grams, but water is same. Now amount of energy that you need to supply to increase the temperature from 30 to 40, is it same for both of the substances? I mean, the mass is different, but the temperature difference is same. You see, 30 to 40, here also 30 to 40. The amount of energy required to increase the temperature from 30 to 40 for different masses, would it be same? Absolutely not. It depends on how much mass you have got. So what I can say is the amount of energy required, let me say that is Q, is directly proportional to the mass of the substance. More massive, more amount of energy I need to supply to increase the temperature for the same difference. Definitely it is true. Now another side, I take one glass of coffee, and I'm going to increase the temperature from 30 degree normal to, again I'm going to heat it maybe to 40 degree. Another side, I'm going to increase the temperature from 30 degrees to 100 degree or 90 degree. Very hot coffee I want. Now in both these cases, the amount of energy that you need to supply to increase the temperature, would it be same? Absolutely not, because it's all about the temperature difference. So in the first case, 30 to 40 degree, you don't have to apply too much amount of energy. But in case of 30 to 100, you need to supply so much of heat energy so that the temperature will rise from 30 to 100. That means the amount of energy required to change the temperature is directly proportional to the temperature difference. Let me say delta T. Maybe delta T is equal to T2 minus T1. In the second case, it is 100 minus 30. So this is a simple way to find out for a given material how much energy you require to increase the temperature for a given mass of the substance. So if I put it together, Q is directly proportional to m into delta T, and always I need to replace by a constant, and that is going to be now C m into delta T, and where C is called as specific heat capacity. Oh my goodness, this C is a constant for a given substance. So how can I define specific capacity here? You see here, Q is equal to mc delta T. This is a standard formula for amount of energy required to raise the temperature for a given mass of the substance, including a constant called specific capacity. Now, how do I define it? Very simple. Now, if I take 1 kilogram of substance, so m is going to be 1 kilogram. And if I want to change the temperature of 1 Kelvin or 1 degree Celsius, if I check the difference in temperature, whether it is in degree Celsius or Kelvin, it is going to be same. So delta T is equal to 1 Kelvin or 1 degree Celsius, both are same. Now I can use this equation, I can say Q is equal to m is 1, delta T is 1, so Q is equal to C. So can I define specific capacity by using this? Why not? I can say specific capacity of a substance is nothing but the amount of energy required to change the temperature of 1 Kelvin, or to increase the temperature of 1 Kelvin or decrease the temperature of 1 Kelvin for a unit mass substance. It can be 1 kilogram mass of the substance. So what would be the unit for this? So what is C from this? C is equal to Q by m into delta T. Q is measured in terms of joule because it's the amount of energy. Mass is measured in terms of kilogram, and temperature difference is measured obviously in terms of Kelvin because it is a SI unit. So specific capacity SI unit we always measure in terms of joule per kilogram per Kelvin. Now my question is, does it depend on the material? I have taken water, two different masses of water, two different temperature difference. What about if I take other object? For example, if I take copper, or if I take some glass rod, or if I take some wood, So if I take different substances, amount of energy required to change the temperature of 1 Kelvin for a same 1 kilogram of mass will not be same. It will be different. For some materials, you need to supply more amount of energy. For some materials, you do not have to supply more amount of energy. And actually found that for water, the amount of energy that you need to supply to increase the temperature for 1 kilogram of water to increase the temperature 1 Kelvin is very, very high, and it's almost around 4,200 joule per Kelvin per kilogram. It means this amount, 4,200 joule amount of energy required to raise the temperature of 1 kilogram of water. How much you are going to raise the temperature? Only for 1 Kelvin if you want to increase the temperature. This amount of energy you need to supply. If you want to increase the temperature from 30 to 32 degrees Celsius, you need to supply 2 times of this. If you want to increase the temperature from 30 to 40, then we have to supply 10 times of 4,200. So this one will exactly give us idea how much energy you need to supply to increase or to decrease the temperature for a given substance. And it is obviously depending on the nature of the substance. For certain material, specific capacity would be different. Thank you for watching this.